All right, so we're going to go over Chapter 8 test. Number 1, it says find the geometric mean between 2, whoops, that's a 2, and 5. Look, if you're not getting number 1 right, chances are you're not going to get 2 and 3 right because you have to use geometric mean. Are we all listening now? A lot of mumbling and commotion going on. Okay. So it says find the geometric mean between 2 and 5. You got to know how to set this up. Look, it's a proportion. It's a ratio. Two ratios set equal to each other. Between 2 and 5, you got to know where to put the variable. Look, the variables go diagonally. I don't know what else to tell you. It's just straightforward just looking at this and knowing where to put the variables. You put them diagonally, and then you put these two numbers right here diagonally as well. So you put 2 and 5 right here. Cross multiply, so that's x squared, and you multiply that, that's 10. You don't leave it like that, you solve for x. So you get rid of the squared by taking the square root of both sides, so that's just the square root of 10. Just leave it like that. There's no reason to change that to a decimal. Just leave it like that. Okay, it's not any easier to change it to a decimal. I've already got my answer. I'm done. Go on to the next problem. That's all you have to do. Okay, I had crazy stuff. I can't even remember who did this, but I mean, I had stuff like this. Square root of 2, and then I had like 2 square root of 5, okay? I mean, come on, what are we thinking, all right? It's just multiply the stuff, it's square root of 10, and look, and I was very, very easy for you guys. Remember I said when you had square roots, like if you had an answer, you didn't have one that came out to this, but let's say you got square root of 8. And remember I said you need to simplify them, but I gave you that, all right? If you left it the square root, there was one, what was it, like 7,300 or something like that? I gave it to you. If you put the square root of 7,300, I gave it to you, all right? I didn't make you change it into simplest form. So I actually was a lot easier than I could have been. I could have been a lot tougher on you. So anyway, you're welcome for that. Okay, let's do the next picture here. All right, let's take a look at this one. On this one right here, we're using geometric mean. I saw some tests, people are trying to use sine, cosine, 30, 60, 90. You don't know what's 30, 60, 90, do you? You don't know any angles in here, so you can't really, well, I don't know, maybe you could find an, but to find x, we're going to use geometric mean. That's what we're going to use. You have to understand what the geometric mean is. Remember what the geometric means are. That altitude is a geometric mean. If for some reason they give you a number here, that would be a geometric mean. If they gave you a number there, that would be a geometric mean. Okay? We just found out how to do a geometric mean, so that you have, when you do geometric mean, it's between two numbers. In this number 1, it was between 2 and 5. So you have to know, and there's basically 3 situations here. Go look it back up. I'm not going to teach it from scratch. Go look that lesson up on YouTube, and you'll see how we set that thing up. But watch. This is the geometric mean. The altitude is the geometric mean between the two segments of the hypotenuse. Do you see how this is broken up into 8 and broken up into this unknown distance right here? So 12 is the geometric mean between those two numbers. So watch, 12 is the geometric mean, so you put a 12 here and here. Between what and what? Well, between the two segments, between 8 and what? Right, a lot of people put x here. It's not x. It's this segment from here to here. And say, what is it, Chandler? It's x minus 8. That's right. Because look, the whole thing is x. This is 8. So this part right here is x minus 8. So you put x minus 8 right here, and then you cross multiply. Okay? And you just solve for x. I don't think the cross multiplication was the problem. We'll just... what was the answer to that? Anybody get that right? Somebody got it right, didn't they? Nobody got it right? Not one person in here got that right? What'd you get? 46? 26. Okay.
It's 200 divided by 8.
All right. So anyway, I'm going to skip some of the arithmetic just because I'll leave that up to you. We're just setting this stuff up for you right now, okay? And then you just cross multiply, you solve for x, and there you go. All right, let's do another one. Okay, here we go. We got to solve for x again, and here's our situation. We've got a right triangle with an altitude drawn to the hypotenuse. Remember what we said? The two legs are both geometric means as well as the altitude. Well, here's a situation where we have one of the legs, and so that's a geometric mean. Well, it's a geometric mean between what two numbers?
3 and 13.
Okay, so let's set it up. Here's our geometric mean. We put them diagonally, right? So this is a geometric mean between the whole thing, which you just said, 13, and what? The segment that's closest to that leg. I don't know what else to tell you. I mean, that's how you set it up. This is a geometric mean between the whole hypotenuse, which is 13, and the segment of the hypotenuse. To see how it's split up into two segments right here? The segment that's adjacent or closest to this side. So it's between 13 and 3. So you cross multiply, so x squared equals what? 39, right? You can't simplify that, so just x equals the square root of 39. Look, I had a lot of people writing decimals for this. I gave it to you. If it was the right decimal, I gave it to you. But is there any reason to even take that and write it as a decimal? It just takes extra time. It takes extra work. Why bother turning it into a decimal? Plus, you could accidentally punch it in wrong on your calculator, right? I mean, that could happen. Has anybody ever done that? Punched in wrong numbers? Sure, it's happened to me all the time. Okay, just keep it like that, and then you're good to go. All right, let's do number 4. All right, look at this one. We've got, it's a rectangle, okay, but basically we're looking at the triangle part of it, aren't we? We've got one side is 80. It's a right triangle. This is 80. This is 30, and we want to solve for x. And so what are we going to use? Are we going to use tangent? Are we going to use anything like that? No, we're going to use what? Pythagorean Theorem. That's right. Okay, we're trying to find the third side of a right triangle. We know two sides. So you're going to find the third side. So it's Pythagorean Theorem. So it's going to be x squared equals 80 squared plus 30 squared. There's no reason to miss this at all. Not any reason. So x squared equals whatever that is. Let's do it. It's 70. Okay, let's just show it on the calculator. So it's 80.
Did you change it?
I did change it. Thank you. 80 squared. Actually, it doesn't matter for this one because I'm not using any trig functions. Okay, and then that equals 7,300, just like you said. And look, take the square root. I let you keep it 7,300, or square root of 7,300. Okay, I gave you credit for that. Technically, I should be a lot tougher. Okay, you should simplify. It's 100 times 73. Square root of 100 is 10. Square root of 73. If I was really going to be hard-nosed about this, and I could have been, this is the only answer I should have accepted. But I was easy on you, and I accepted this, or a lot of people put this into a decimal, put it in your calculator and got a decimal. I accepted that as well. All right? This technically is the way you should write it. And there are some teachers who are going to force you to write your answer like this, and they won't accept anything else. All right? But again, I took it easy on you. All right, this is number 5. All right? And we have a distance from here perpendicular to the side right here. Okay, you guys paying attention? So it's an isosceles triangle. This is a perpendicular. So what do we know? We've learned this a long time ago. When you have an isosceles triangle and you drop a perpendicular to that third side right here, the non-equal side, where does it hit? Hits right in the middle, at the midpoint, okay? So watch, if the whole distance, ooh, that was a little sloppy. If that whole thing is 24, is that right? Yeah, yeah, so it's an equilateral triangle. That's 24. What's this little bit right here? That's going to be 12, okay? And what are we trying to find? We're trying to find this right here. We're trying to find x. Okay? So it's Pythagorean Theorem again, isn't it? All right? Because look, I've got a right triangle here, and I just have one of the missing legs. I know the hypotenuse this time, but here's a leg, and this right here is 12. You got to make sure that you understand that that's 12. And again, it's something that we talked about a long time ago when you have an isosceles triangle perpendicular and all that good stuff. Okay, so what do? We just go x squared plus 12 squared equals 24 squared. Subtract 12 squared from both sides, right? And then you take the square root of it, whatever that is. So let's punch that in the calculator. So let's go 24 squared minus 12 squared. And that equals 432. And look, I let you keep it 432. If you simplify it, let's see. I think 144 goes into, or 3 goes into this 144 times. Okay, so watch. It's 144 times 3. Square root of 144, that's supposed to be a 144, is 12 square root of 3. If you threw that into a calculator and got 20.78 or 20.8, I accepted that as well. I accepted that. I accepted that. I accepted the fact that you put it into a calculator and got that. Okay? Dave.
I was wondering, are you okay with, like, since it's a 30, 60, 90 triangle, if we just said that?
You could do that. Yeah, you could do that too. That's fine because watch. It is a, I didn't really draw it like that, but it is a equilateral triangle, so you know that that has to be 60 degrees right there. You know, when this is a perpendicular to an isosceles triangle, it also bisects this angle right here. So if this whole angle is 60, that's 30, okay? And you're absolutely right. You could have done it that way. This is the longer side. Remember the longer side? The longer side is the square root of 3 times the short side. Well, you know the short side is 12, so guess what? X is what? 12 times the square root of 3. Good. I hadn't even thought about that, but you're absolutely right on this particular one. Does that make sense? Okay. All right, good. Thanks for bringing that up. Let's go to the next one, number 6. Okay, this is number 6, and you have to solve for x. So x is just one of the sides. Well, look at this. We just talked about 30, 60, 90 a second ago, didn't we? Well, what is this kind of triangle? Right. If that's x, that's x. So these two sides are equal to each other. So what's true about these two angles right here? They're 45 and 45. That's right. So that's 45, 45, 90 triangle, right? Right? Because it's isosceles. That means the opposite angles are equal to each other, and they add up to 90, so they're both 45. So what's the relationship between on a 45, 45? Remember, hypotenuse is what? Square root of 2 times one of the legs. That's right. Now what do we know here though? We know the hypotenuse. So you put 30 in for the hypotenuse equals the square root of 2 times one of the legs. Our leg is x, isn't it? Divide by the square root of 2. Now technically if you would have left it like this, I probably would have given it to you just because I was trying to give you every point possible, okay? But really you're not supposed to leave it like this. What do we do with this thing?
You're supposed to get it on top.
Okay, get the square root on the top, right? So square root of 2, square root of 2. So what do we get? We get, we get 30 square root of 2 over what? 2. This simplifies though, doesn't it? And this is a reason why you get rid of that radical, because there are times when you can simplify more. So that goes once, that goes 15 square root of 2. That's it. Okay. Again, if you wrote that as a decimal, I gave that to you as well. But 15 square root of 2 is the answer that you should get. All right, let's move on. Okay, here's number 7. Here's our picture. It says this is a parallelogram, okay? So we know it's a parallelogram, which means the opposite sides are equal, the opposite sides are parallel, blah, 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 all that good stuff, okay? Let's see what else they tell you. They tell you that AD is 14. So let's just put a 14 right there. It says angle D is 60 degrees, so that's 60 degrees. And they want you to solve for AF. Oh, the F is right here. Okay, we'll just call it X. Is that all right? Just to make it easy. All right. So look, you got a right triangle. You got 60. So what's this angle right here? It's 30. So guess what we have? We have a what? 30, 60, 90. All right. So problem is we got a hypotenuse and we have a longer side, don't we? Sorry, we have a hypotenuse right here, and we have a longer side right here. Do we have a relationship between the longer side and the hypotenuse? No, we got to know what? You got to know the short side. Okay, you could do that, but I got 30, 60, 90. Look, some of you guys are going in directions that I really don't intend you to go. You could have done that. You could have done a trig function to get that, okay? But you could have also done this. If I know the long side, what's the short side? It'd be 14 what? Divided by the square root of 3, wouldn't it? Okay, so just write it like that because we don't have to simplify it right now. 14 divided by the square root of 3. So what is the hypotenuse to the short side? I'm sorry, this, right? What am I trying to... I'm sorry, not hypotenuse. What's the long side? Am I doing that right? Let me write this down. I'm getting confused because I'm skipping too many steps. Watch. The long side...
The short side's going to be...
Let me write this down. The long side is what? The square root of 3 times the short side, correct? Okay, and then the what? Hypotenuse is equal to twice the short side. Okay, so let's go from there. How do I find the short side? What do I know? I know the hypotenuse, right? Yeah, so it was a lot easier than that, wasn't it? So, for some reason, this looks like it's the hypotenuse, but it's not. This is the hypotenuse. I got to keep reminding myself. Right, so the short side is just 7. So I had a little brain freeze right there, but that's 7. And then now, if we know the short side, we can find the long side by doing what? Just multiplying it by the square root of 3. So it's 7 square root of 3. So the math was pretty easy on that one. If you understood that this was the hypotenuse and the short side is half of the hypotenuse, okay?
Could you use,
You could, no, well, if you knew the other side, you could use Pythagorean Theorem, but why not just use the fact that 30, 60, 90? You couldn't use Pythagorean Theorem to begin with because you only know one side, all right? So the way that I did it right there was probably the easiest mathematically. You didn't have to have a calculator, did you? You just have to know what's true about 30, 60, 90 triangles, and you should have been able to do that fairly easily, all right? I got a little mixed up right here. That's why I had to go to this. Now, I didn't do that on purpose, but that's a good example for you, because if you look at it and are trying to do too much in your head, always go back and write down what you know. Okay, write this stuff down so that you remember, or it's right in front of you, and you don't have any question of what you're trying to remember. Because I was trying to do too much in my head, and it's way better to write the stuff down. Okay, that was what, 7? Let's do 8. All right, laugh if you will, but here we go. I got 30, 60, 90 triangles, right? So I'm thinking 30, 60, 90. So let's see. We got a right angle right here. So I don't know. What do you want to do first? Let's do this. Let's solve for x, okay? Because look, I've got a 60 degree. So what is x? X is the what? It's the long side, okay? And what are we given here? We're given the hypotenuse. So what do I need to find? The short side. So what would this side right here be? It's half of the hypotenuse. That's right. What's half of that? That's easy. It's 4 square root of 3. That's right. So the short side is 4 square root of 3. So now what is the long side? It's what?
It's going to be 12.
It's 4 square root of 3 what? Times square root of 3. That's right. Because remember, the long side is the square root of 3 times the short side. This right here is the short side. This is your square root of 3. And then that's easy to do. Square root of 3 times square root of 3 is 3 times 4 is 12. All right, so that's what x is equal to.
What if you use sine and got the same thing?
You could, but this is better. Okay, this is the second time I've been asked this question. I said earlier when somebody asked me, could I use the sine? Yeah, you could. You could use trig functions to find this stuff. But as soon as you see 30, 60, 90, use that because you can get exact answers. What if I said your answers have to be exact answers? Then you don't want to. Well, actually, since it came out to 12, it might come out to an exact answer. But what if it asks you for the short side? If I use sine, cosine, tangent, you wouldn't get this, would you? You would get a decimal approximation.
I'm just saying, like, the way that was, it was easy.
You could, but I didn't even need a calculator. If you were going to use sine, cosine, tangent, you would need a calculator, wouldn't you? Let's do y real quick. So watch. This is the short side. This is the hypotenuse. So what's true about the hypotenuse and the short side? It's twice this. So what is this? It's 24. Easy as that. Okay? All right. So we did up through what? Number 8. So you're making me do more work, but I'm going to just because I want you to do well on this. Okay? I'll go through 9 through 20 at home sometime. So sometime this weekend, check. I would check tomorrow. Don't check tonight. I'll probably do it tonight, put it on late tonight. Check tomorrow, and you'll see 9 through 20 on there. Okay?
You should be used to it.
You're welcome.